Lesson 1.6 is on other simulation methods, part 2. The first way we did simulations was using cards and dice, and although that was faster than having an athlete go down and attempt many performances, it still was pretty time consuming. We also used a random digit table, which works much, much quicker. But in this section, we're going to learn how to use an applet. So our textbook publisher has a website that has a simulation applet for different types of problems. And we'll be using different types of applets throughout this course. And the nice thing about using the applet is that we can do lots and lots and lots of trials many times. Also, it avoids some of the problems that can occur when we do simulations using coins and cards, particularly if you use cards and you don't shuffle well, if you use a coin and you sort of do lazy coin tossing. With a random digit table, some of those problems are avoided, but it is still sort of time consuming and it's easy to make mistakes. So you have a link to the applet provided for you. The address is there as well. And then when you get to the applet page, you can click on proportion or number of successes given ability. But again, you'll have the link provided to you. So we're going to do example number 1, which says enter the numbers from problem number 1 in the previous section. And that problem asks you to simulate 15 foul shots by a player who normally makes 70% of her shots. So in this case, we would use the decimal 0.7 for the ability. The attempts would be 15, and we're going to do 100 performances this time. When we did this simulation in other ways, we just did like 2 using a spinner, or we did just 1 using random digits, but now we're going to do 100 performances. And you have kind of a picture in your notes of what that would look like on the applet, but I'm going to show you in a little bit more detail. So this is kind of a screenshot of what that applet looks like. The numbers that you need to put in, there's spaces for each of them. So notice here we have the athlete's ability, and that has to be entered as a decimal. So I did 0.7 here. The number of attempts is 15, and that goes in this box. And then the only other thing that you have to put in is the number of performances that you want to do. And I usually do 100 because that makes calculating the probability really easy, right? Because we just count the number of dots out of 100. You can really set that to be any number you like, but in general, we're going to keep that at 100. And then all you have to do is click this button right here that says add more trials. And what that's going to do is it's going to do 15 free throws 100 times. Now it's going to give you a dot plot of the results, and the dot plot is showing you the simulated number of successes. So again, if we look at the dot plot and think about what that's showing you, remember we know that she has the ability to make 70% and she's attempting 15 of them. 70% of 15 is 10.5. So notice that most of the results are around 10 or 11, which is what we would expect. Now, going back to the notes, what each dot on that dot plot represents is the results of one trial of 15 free throws. So one trial is made up of 15 free throw attempts. Now, the next question says, based on your results, what is the probability that the player will make 13 of the 15 shots or fewer if her ability is to make 70%? If we go back to the dot plot, we want to count how many of those dots are at 13 or more. Now, you have a couple of options here. One is that you can actually count the dots on your screen, which shouldn't take too long. But down at the bottom, you have this nice tool that will do that for you. So you have some drop downs here, and we want to count the number of dots. We have this drop down that we can change to greater than or equal to, and you put in the number here that you're looking for. So I put in 13, and then I clicked the count button, and it drew a little dotted line in there, and it's counting all the dots from there greater. So it counted that up for me, and it told me that there were 15 dots that were greater than or equal to the specified value. Now, keep in mind, if you try this at home, you are going to get a different dot plot than I will, because you're going to get your own set of 100 groups of 15 free throws. So you might get a different result, and that's okay. Everybody can do this lots of different times and get different results, but they should have a similar pattern or shape to them. So since we had 15 dots out of 100, the probability of that happening is 15%. Example 2, we're going to use the applet to simulate 20 at-bats by a player whose lifetime batting average is 275. and we want to find the probability that this batter will hit 15 or more out of 20 at-bats. The ability is 0.275. The number of attempts is 20 because he's taking 20 at-bats. We're going to do 100 again for the number of performances. And by the way, there's space in your notes for you to sketch the dot plots after you create it using the applet. So here's a screenshot of what happened when I ran the applet. Notice I put in that first box, 0.275 for the ability. I put the number of attempts at 20. And again, I put the 100 performances in there, and then I clicked the Add More Trials button. Now, in this case, his batting average is only 275, and he's doing 20 at-bats. So 27.5% of 20 is 5.5. So what we would expect is that he'd get about 5 or 6 hits in 20 at-bats. And notice that most of the results are right in that range, between 5 and 6. As we get further away from that, either to the left or to the right, we have fewer and fewer dots. Because if his batting average was 275, we would not expect that he would get 10 hits out of 20. That would be 50%. Likewise, we would not really expect that he would get only 2 hits out of 20 because that would be 10%. So we can go ahead and sketch that dot plot in your notes. And then the question asked, based on your results, what is the probability that the player will hit 15 or more out of 20 if his batting average is 275? And in this case, that would be 0%. We did not have a single result from our simulation that was at 15 or more. Now, that doesn't mean that it's impossible. It just means that in this case, it didn't happen in 100 simulations. But if you did more simulations, like maybe 1,000 or 10,000 of them, you might actually get that result once or twice. But it's not going to happen very often because it's so unlikely. Finally, example number 3 says use the applet to simulate 18 drives by a golfer who has a lifetime average of hitting 82% of her drives on the fairway. What's the probability that she will hit 3 or fewer of her drives in the fairway? So our ability would be 0.82. The number of attempts is 18, and the number of performances, again, is 100. So here I have a screenshot of the applet when I conducted this. Notice I put the ability in as a decimal. 18 was the number of attempts. We did 100 performances again. And this time we're looking for the probability that she will hit 3 or fewer into the fairway. Notice again in my simulation when I ran this, I did not have any where she hit fewer than 9 in the fairway because her ability, 82%, is pretty good. And if she hits 82% of 18, that would be 14.76 shots. So we would expect that most of the time she would get either 14 or 15 out of the 18 in the fairway, which is what our simulation shows. So based on the results, the probability that the golfer will hit 3 or fewer out of 18 in the fairway, again, is 0%. Please do homework 1.6 in your assignment packet, and you will need the applet to do this homework tonight.